linear equation of three variables. So the another linear equation is a to x plus b to y plus c to z equals to d2, and the another one is a3x plus b3y plus c3z equals to d3. This is the linear equation. This equation is called system of linear equation of three variables. In the first equations, in the case A1 is the coefficient of x. In the second equation, B2 is the coefficient of y. And in the third equation, C3 is the coefficient of z. In the first equations, A1 is greater or equals to the B1 plus C1. In this case, we find the values of x from the first equations. And from the second equations, in the case B2 is greater or equals to A2 plus C2, we find the values of y from the second equation. And the third equations, C3 is greater or equals to A3 plus B3. In this case, we find the values of z from third equations. So these equations can be solved by the iterations process also. The first iteration process is the Jacobi iteration process, iterations, and the second one is Gauss-Seidel iteration process. In the both cases, both method, the condition should be applied. These conditions, these coefficients of x, y, z, which is called diagonally dominant coefficients. So the first equation, we find the values of x, which is 1 by a1 d1 minus b1y minus c1z. And the second equations, we find the values of y equals to 1 by b2 d2 minus a2x minus c2z. And from the third equation, we find the values of z 1 by c3, which is equal to d3 minus a3x minus b3y, which is the equation. So in the Jacobi iteration, by the iteration process, in Jacobi's iteration method, in the Jacobi iteration method, we first assume the initial guess. The initial guesses are the initial solutions, which is equals to x equal to 0, y equal to 0, and z equal to 0. So from the equation 1, the first iteration, the values of x, y, and z, we find x1, which is first iteration values of x, which is 1 by a1, this d1 minus b1 y, the initial value, and c1, the initial value of z, which is denoted by z0, and the first iteration values of y, 1 by b2, which is equal to d2 minus a2 x, initial values of x, minus c2, initial values of z, and the first iteration values of z is equal to 1 by c3, which is equal to d3 minus a3, initial values of x, and b3, initial values of y. So this is the first iterations. We find the values of x, y, and z from the initial guesses, the values of x equal to 0, y equal to 0, and z equal to 0. Similarly, in the second equations, we find iteration, we find the values of x, y, and z by using the values of x, y, z of the first iteration, which is the second iterations, 1 by a1 d1 minus b1 y, the first iteration values of y, and we use the first iteration values of z, which is written z1, and y2. Y2, the values y in the second iterations, 1 by b2, which is equal to d2 minus a2. The values of x in the first iteration, we write here 1 minus c2 z, the 1. Similarly, the second iteration values of z, which is written z2, 1 by c3 d3 minus a3, the values of x in the first iterations, the values of y of the first iteration. Here, in the same way, we find the values of x, y, z in the nth iterations if there is minimum even. So, in general form, the values of x of n iterations is 1 by a1 d1 minus b1 y n minus 1 minus c1 z n minus 1th iteration value of z. And the nth iteration value of y is 1 by b2, which is equal to d2 minus a2, the values of x in the n minus 1th iterations, the values of z in the n minus 1th iterations. Similarly, the value of z of nth iterations, we had 1 by c3 d3 minus a3, the values of x in of n minus 1 iteration, minus b3, the values of y of n minus 1 iterations, or n equals to 1, 2, 3. This is the formula to find out the values of x, y, and z of the system of linear equations by Jacobi method. Solve 28x plus 4y minus z equal to 32, x plus 3y plus 10z equal to 24, 22x plus 17y plus 4z equal to 35. By Jacobi iteration method, the error should be correct to 2 decimal places. So, in this equation, we find the values of x from the first equations. In the first equations, this is the first equation. From first equation, we find the values of x because this coefficient is greater than the sum of the another coefficient 4 and 1. So x equals to 132 minus 4y plus z divided by 28. And the third equation, we find the values of y. Because the coefficient 17 is greater than the sum of the coefficients 2 and 4. So from the third equation, we find the values of y, which is 1 by 17, 35 minus 2x minus 4z. And second equation, we find the values of z, which is 1 by 10, because this 10 is the highest coefficient, which is greater than the sum of the coefficient of x1 and 3, which is equal to 24 minus x minus 3. So from equation 1, we find the values of x. From equation 2, we find the values of y. From equation 3, we find the values of z. So from the Jacobi equation, we guess the initial solution or initial guess, which are x equal to 0, y equal to 0, and z equal to 0. We assume the initial guess. So in the first iteration, we find the value of x and y and z, which is from 1, 2, and 3. From 1, x equals to 1 by 28, 32 minus 4 into 0, 4 into 0, 0 plus 0. So 32 by 8, 32 by 8, which is equal to 1.14285. And from the second equation, we find the values of y, which is equals to 1 by 17, 35 minus x equal to 0, z equal to 0. These are the initial guesses of x and z. 0, so 35 by 17, which is equals to 2.0588. And the z from the third equation, 1 by 10, 24 minus 0 minus 0. So 24 by 10 equals to 2.4. These are the values of x, y, z in the first iteration. So by the help of the initial guesses, x is 0, y 0, z 0, we find the values of x, y, z, of x, y, z. So in the second iteration, the values of x is obtained by using the values of x in the first iteration, which is 1 by 28, 42 minus 4. Minus 4, the values of y is 2 into 2.0588 plus z. Z is 2.4. So this is equals to 0.9345. And the values of y is also obtained from the other values of x and z in the first iteration, which is equal to 1 by 17, 35 minus 2 into the values of x in the first iteration is 1.14285 minus 4z equals to 2.4. This 2.4 is the value of z in the first iteration. So this equals to 1.3597. And the value of z is 1 by 10, 24 from third equations. The values of x in the first iteration is 1.1421485. This minus 3y. The values of y in the first iteration is 2.0588. So this equals to 1.6681. Similarly, we find the third value in values of x, y, z in third iterations. So these can be the third equation. We find the values of x from the equation 1 by using the value of y and z, this value of y and this value of z. In 1, we find the values of x is equals to 1.0082. And similarly, in third iteration, the values of y is obtained from the equation 2 by using the values of x is the first iteration, this value, and z in the first iteration 1.681. By putting this value in equation 2, we obtain the values of x is 1.5564. And the values of z is obtained from the equation 3 by using the values of x and y in second iteration. So z equals to 1 by 10, 24 minus x is 0.9345 minus 3 into y is 1.3597. So we find 1.3597 1.8986. Similarly, in the fourth iteration, 5564 minus 1.8986. So after calculation, we get 0.9883. And then to find the values of y in the fourth iteration, we use the values of x from this third equation and from values of z from third iterations. So 1 by 17, 35 minus 2 into 1.0082 minus 4 into 1.8986, which is equals to 1.8935. And then to find the value of z by using the values of x and y in the third iterations. So 1 by 10, 24 minus x. X is 1.0082 minus 3 into y is 1.5564. So we calculate by using the values of x, y, z in the fourth iteration. So from 1, the values of x we find by using the values of y and z from this y and z from the fourth iteration. So this x equals to 0.9949 and y equals to 1.5114 and similarly z equals to 1.8351. 9931, 1.5058 and 1.8471. So in the fifth iteration, the values of x is after two decimal places, there are same number, 99. So either is correct to two decimal places. So in the fifth and sixth iteration, the difference between the values of y in the fifth and sixth iteration is only 0. So there is no accuracy in the two decimal places. So in third one is 1.83, this is 1.82. Equation 1, we use the value of y and z from sixth equation. We find 0.9937 and 1.5074 for 1.1.8489. Here we stop the iterations because the accuracy is correct to two decimal. After decimal, two terms are same, 0.84, 0.84. So the error is also correct to two decimal places. So our iteration process is in. Hence, the values of x, y, z in two decimal places. Therefore, the values of x is 0.99, y is 1.50, and z is 1.84. These are the solution by using Jacobi iteration.